A particle starting from rest moves in a circle of radius r. It attains a velocity v0 meters per second in nth round. Its angular acceleration will be. So radius is given and it attains velocity v0 in nth round. It performs n rounds in a circle. So how much would be the angular acceleration? This is the question. Tell me. See, now no relation of acceleration and time is given. So we'll consider that acceleration is constant. Okay. And I can say v is equal to I can say u plus at. But what will be this a? It will be tangential acceleration, right? Yes or no? Okay. And then it performs n revolutions. Okay, it performs n revolutions, right? Performs n revolutions. Then we can find it out. U is equal to 0. This is equal to 0. Okay. And V will be equal to V naught. V is equal to V naught. So it is the AT multiplied by T, time taken. Okay. So can we find out time from this? Actually, I think. Okay. So which formula should we use? Should we use this one or any other formula? Which is the given quantity? Is time given? Time is not given, right? Which thing is given? V is given, final velocity is given. Okay, so we can use V square equals to U square plus 2 times acceleration, which will be tangential acceleration, multiplied by displacement. Okay, distance actually. So this is given because it is performing n revolutions, right? How much is distance covered in one revolution? 2 pi r. How much will be distance covered in n revolutions? N times 2 pi r. Okay, this is given, this is given, this is given. Okay, so this is v naught square is equal to, this is 0 plus 2 times of tangential acceleration multiplied by, you have s is equal to n times 2 pi r, n multiplied by 2 pi r. So you want this at, take other things on the other side, so you get at equals to v naught square divided by, it is 4 pi, right? 2 times 2, 4 pi multiplied by nr. Okay, and then you want angular acceleration, not the tangential acceleration. So you can say that tangential acceleration is what? This is equal to, this is equal to r times alpha, and move that r on other side. Okay, so then you get alpha is equal to what? V naught square, and that r will go in denominator, so it is 4 pi n r square. Okay, so it is option C. Okay, this is clear. Okay, you can solve this in other way also. So what will be that other way? You can find out, but that will be lengthier way, right? So using v naught, you can find out final angular velocity. Okay, omega at time t will be equal to what? V naught upon r. Okay, you can substitute that. So you can use this equation, omega t square equals to omega 0 square plus 2 times alpha theta. Okay, and how much will be theta? So in one revolution, theta would be equal to 2 pi. In n revolutions, theta would be equal to what? N times of 2 pi. Actually, it will take same time only. Okay, not the other way, or shall I explain? Shall I explain? Yes, no? Okay. Let us see next question. A wheel is rotating at 900 rpm about its axis. When the power is cut off, it comes to rest in 1 minute. The angular retardation in radians per second is. So there is a wheel which is rotating at 900 rpm. Okay. So n is given. Initial frequency is given. Okay. You can call it n. You can call it uh, f. Okay. It is equal to 900 revolutions per minute, right? And when power is cut off, it comes to rest in 1 minute. How much is angular retardation? This is question. Tell me, what can we do? This is simple, straightforward question. Alpha equals to what? Final angular velocity. Omega t minus omega naught divided by time. Okay. And this is given in revolutions per minute, and time is also given in minute. So we don't need to change anything. Okay. So omega t is 2 pi times, this is 2 pi times nt, I can say final what? Frequency. Okay. Minus you have omega naught, which will be 2 pi times initial frequency. 2 pi is taken common. Okay. So sorry, not 2 pi. Nt is equal to 0. Okay. Final angular frequency is equal to 0. This is given, right? So you have 2 pi multiplied by, this is 900 minus, okay, not 900. This is 0 minus 900. 0 minus 900 divided by 1. Okay. So am I doing some mistake here? This is coming, this is revolutions per minute, and this is in 1 minute per minute per minute. Oh, no, no, no. I'm sorry. We need to convert this. Okay. That minute will not get cancelled out. Okay. This is a blunder. Okay. So this is how many RPS, revolutions per second? 60, right? So it will be 15 RPS, right? Yes, 15 RPS. And T is equal to 60 seconds. Okay, T is equal to 60 seconds. So we can put the values here. 2 pi multiplied by nt is 0. This is 15 divided by 60, not 16, 60. Okay. So then this is 4. So right. Answer is pi by 2. Alpha equals to pi by 2. Okay, option A. All right. So we need to be careful about units. Okay, I saw revolutions per minute and here minute. I thought it will get cancelled out. Okay, doesn't get cancelled out. This is revolutions per minute. It comes in denominator. This minute is also in denominator. Okay, so I was doing a very silly mistake. Anyway, this is clear, right? Okay, let's see next question. The motor of an engine is rotating about its axis with an angular velocity of 100 revolutions per minute. It comes to rest in 15 seconds after being switched off. Assuming constant angular deceleration, what is number of revolutions made by it before coming to rest? Yes. Tell me what we can do. How many questions? So actually these are in different exams, but these kinds of questions are asked. Okay. In NEET also they are asked based upon this thing. Okay. So tell me what we can do here. Motor of an engine is rotating about its axis with angular velocity of 100 revolutions per minute. Okay, first of all, we'll convert this to revolutions per second. So omega 0 is 100 divided by 60. Okay, that is 5 by 3. Okay, that is 5 by 3 RPS. Okay, 10 by 6 or 5 by 3. It comes to rest. So omega t, no, this is not omega, this is revolutions. Okay, so this is frequency and not nt. It is nt is how much? 0. Okay, it comes to rest in 15 seconds and t is given 15 seconds. Okay, and you want number of revolutions. How can you find number of revolutions? Okay. Now this is, I can say this is final frequency. This is initial frequency. This is final frequency. Can I find out average frequency? Because this is uniform acceleration, okay, or uniform retardation. You can find out you can find out average frequency or average angular velocity. What will be that? It will be just addition of these two divided by 2, right? Yes, no. Just like in case of uniformly accelerated motion, what will be average velocity? It is u plus v upon 2. Okay, so this is uniform angular acceleration. There is analogy, right? Similar to that. Okay, so I can say average frequency will be equal to n naught plus nt upon 2. That is equal to, what's that? This is 5 by 3 and this 5 by 3, you have 5 by 6. Okay, so n is equal to 5 by 6 and the time is given 15 seconds. So how many revolutions will it perform? So number of revolutions, okay, n is suppose number of revolutions, right? So number of revolutions will be equal to what? So see, frequency is the total number of revolutions divided by time. Okay, I can say n is equal to, small n is equal to what? Number of revolutions divided by time. Okay, so number of revolutions is n into t. So that is 5 by 6 multiplied by 15. Okay, this is 3 times 2 and this is 3 times 5. Okay, so 3 and 3 will get cancelled and this 5 times 5 is 25. Oh, 12.5. Sorry. 12.5. How did I find 22.5? What was I thinking? Anyways, that doesn't matter. Okay, so answer is 12.5. Is it clear? Yes, no? Okay, so this is one method and this is a quick method actually. Okay, or you can say this is a trick. Now I will tell you using uh, kinematic equations of motion. Also, you can find it out how many revolutions does it perform. It will take some time. Okay, but still you should attempt it because this is sure shot. Okay, so just use this equation. S is equal to ut plus half at square, right? What is S? Sorry, not S. Uh, use angular equation. Okay, so theta equals to what? Omega naught t plus half of AT multiplied by T square. This equation or which one? T is given, right? T is given. Okay. So you can find out AT. Okay, you can find out AT. What will be AT? Oh, A I have to replace by alpha. Okay. You can find out alpha. What will be alpha? Alpha is final angular velocity minus initial angular velocity divided by the time. So that will be equal to, okay, that will be equal to omega t is 0 and initial is 2 pi times initial frequency, you can say, okay, n naught, and divided by time is given, time is 15. Okay, just substitute that here. So what do you get? So this will be 2 pi multiplied by n naught, okay, into t, plus half of alpha is this thing, okay, minus 2 pi multiplied by n naught upon t into t square. This t will get cancelled out with this t square. What will be theta? Okay, have you understood till now? This is total angle covered. It will be equal to just your initial angular velocity times t plus half of alpha times t square. We have used this formula. I have substituted initial angular velocity 2 pi times n naught, and I have found alpha. Alpha is omega t minus omega naught upon t. Omega t is 0, omega naught is 2 pi n naught. Okay. So then what will be theta if it performs n revolutions? How much will be theta? It will be n times 2 pi, right? How much is angle covered in one revolution? Okay. Angle covered in n revolutions, n times of 2 pi, right? Now you can see this pi, pi, pi will get cancelled out. Pi, pi, and pi will get cancelled out. And you will get, see, 2 also you can cancel it out. This 2, 2, and this 2 will get cancelled out. And after that you have n naught times t minus, here you have n naught times t divided by 2, n naught times t upon 2. Okay, so that is n naught times t divided by 2. Okay, so that is equal to how much? n naught is, n naught is how much? It's 5 by 3. So it is 5 by 3 multiplied by t is 15 upon 2. Actually the same thing, right? Okay, so this is 7.5, or this is 15. 15 by 3 is 5. 5 times 5 is 25. 25 by 2 is 12.5. So n is equal to 12.5. Yes, no? Okay. Quicker way is which one? Just find out average frequency, because see, you can remember in one case. Suppose you have starting point, some starting point, okay, where you have some angular frequency. It is revolving with some angular frequency. Then at some time t will stop. So for this case, you can just remember this formula, that the number of revolutions will be how much? N naught into t upon 2. Okay. But you can have different cases. Different cases like you have some initial angular frequency. Okay. You have some initial frequency. You have some frequency at time t. It doesn't come to rest. Then what should you do? You can use this method. It will take some time, but this is quick. Anytime you can do. How much is average? It's just n naught plus nt upon 2. Okay. Find out average frequency. Number of revolutions is just average frequency into time. Yes, no? This is simple, right? So then, okay, I thought, okay, I will just erase the solution of this. I don't know. No, there is lot of explanation. That's why I kept, I guess. Okay. So my sheet was prepared long back, so I don't remember. Why did I keep it? Sorry. Yes, I should have. Okay. For a particle in uniform circular motion, the acceleration a bar at a point p r theta on the circle of radius r is measured from x-axis. Okay. Acceleration a bar at point p r theta on the circle of radius r. Here theta is measured from x-axis. So now, okay, answer is option C, right? Because it was marked. Okay, so let me explain this. Or is it clear? Yes, no, not clear. Okay. So question is it clear, Ganga? Okay. All right. So this is actually simple question. Okay. So what you have centripetal acceleration, right? Which is given by this formula. Omega square r bar into r cap. Okay. Or omega square into r bar. And omega is equal to what? Omega is equal to v upon r. Square of that will be v square upon r square. So that r square and this r will get cancelled out. That's why you have v square upon r. And then this r bar you can write it as r into cos of omega t into I cap plus sine omega t into j cap. Okay. Solving that you get this thing. Okay. V square upon r cos of omega t, which is theta, into I cap plus v square upon r sine of omega t into j cap. Okay. So this is the answer. Option C. Okay. So this is not difficult, right? Let's see next question. A particle moves along a circle of radius 20 by pi meter with constant tangential acceleration. If the velocity, this should be if the velocity of particle is 80 meters per second at the end of second revolution, after motion has begun, the tangential acceleration is. So tell me what you can do. So this is actually very simple. So tangential acceleration will be equal to, I can say, v at time t minus v naught divided by the time, right? Yes, no. So how can you find time? You have velocity, okay, and you have this thing, radius. Okay, let's do this thing. We can find it out using this method also, but I can say at is just equal to r times alpha. Okay, r is given and this final velocity is also given. So initial velocity is given, velocity at time t is given, velocity at time t is 80 meters per second, initial velocity is v naught equals to 0, and time is given. Is the time given? Okay, it takes 2 revolutions. Okay, it takes 2 revolutions. So it is accelerating. Okay, so how much would be the time? So we can find out its average velocity. Average velocity v average will be equal to what? Vt plus v naught divided by 2. Okay, and then you can find out the time period. So I can say time period is t. So V average will be equal to 2 pi r upon t. Okay. And then t will be equal to 2 pi r upon V. Right? Yes, no? So this is 2 pi r divided by 80. Okay. This is the time period. And the time taken will be twice of this. Okay. So it will be 4 pi r upon 80. Okay. So you got the time period. Sorry, you got the time. You have final speed, initial speed, and you want acceleration. Okay. So I don't need to do this. The tangential acceleration will be just equal to Vt minus V naught divided by this time. Okay. So V naught is 0 and Vt is 80. 80 divided by 2 pi r upon 80, that upon 80, not 2 pi r, 4 pi r. Okay, because t is equal to 2 times of average time period. So 4 pi r upon 80, that upon 80 will go to the numerator. So how much will this be? 80 times 80. This is 6400 divided by r is how much? 20 by pi. Okay, this is 20 by pi. So 80 times 80 upon 4 pi into 20 by pi. So pi and pi will get cancelled out. 20 times 4 is 80. 80 and 80 will get cancelled out. So answer is 80. Okay, answer should be 80. 80 is not there. Did I do some mistake? Or did I do a mistake here? Oh, I have done a mistake. Right? Here only. It's 40, not 80. Okay. There was a calculation mistake. So the answer would be 40. Okay. Meters per second square. It's option B. Okay. So now I have taken very twist and turns. So I will explain what I have done. Okay. So see. Okay. You have initial velocity, it's 0. You have velocity at some time t, it's 80. Okay. You can find out average velocity, right? Average velocity will be initial plus final divided by 2. So V average is 2 pi r. Okay. It is initial plus final divided by 2. How much is that? 80 plus 0 upon 2. So average velocity is equal to 40. Okay. This is equal to 40. Clear till this point? Yes, no? Then you can say average velocity is equal to 2 pi r divided by average time period. Right? It is equal to 2 pi r divided by average time period. So average time period t will be equal to 2 pi r divided by average velocity. Okay. 2 pi r divided by average velocity is 40. So substitute that. Okay. So you got average time period. Right. And then, sorry, this is capital T. It takes 2 revolutions. That means how much is the time taken? It is 2 times of the average time period. Right. This is time taken for 1 revolution. Time taken for 2 revolutions will be how much? 2 times of this. So it is 2 times of t. Okay, this is the time. Okay, so therefore the tangential acceleration is final tangential velocity. Okay, tangential velocity at time t minus initial velocity divided by time. Okay, so final velocity is given, it's 80. Initial is given, initial is given, it's 0. Okay, so it is v minus 0 or at minus 0 divided by this time, and time is how much? Time is equal to 2 times of t, so t is equal to 2 pi r upon 40. So the small t will be equal to 4 pi r upon 40, right? So it is 4 pi r divided by 40. Okay, so that 40 I will take to numerator. See, this is 80 divided by 4 pi r upon 40, that you can take to numerator. So you take it to numerator. So it is 80 times 40, and in denominator you have 4 pi r. R is given, r is equal to 20 by pi. Okay, so it is 4 pi multiplied by 20 by pi. Okay, so that pi and pi gets cancelled. So you have 20 times 4, that's 80. 80 gets cancelled. So your answer is 40 meters per second squared. Is it clear? Is there any question? Okay. So let's see next question. Particle moves such that its position vector r bar is equal to cos omega t into I cap plus sin omega t into j cap, where omega is constant, t is time. Then which of the following statements is true? Okay, for the velocity v bar and acceleration a bar of the particle. So this is repeated question. Tell me. V is perpendicular to r bar, a is directed towards the origin. Right. It is option D. Good. Next question. A particle is moving along a circular path with constant speed of 10 meters per second. What is the magnitude of change in velocity of particle when it moves through an angle of 60 degree around the center of the circle? Question is, what is magnitude of change in velocity? So let's draw a circle. Let's suppose it moves from this point to this point. Let's draw it. Moves through 60 degrees, right? Okay. Moves through 60 degrees. And it moves with constant speed, 10 meters per second. What is magnitude of change in velocity? This is the question. Okay. See, this is initial position A, this is position B, and this angle is 60 degrees. Now, velocity at this position will be directed like this. Velocity at this position will be directed like this. Okay. So this is suppose your VA bar, this is VB bar. How much will be the angle between VA bar and VB bar? Angle between this and this radius vector, you can say, is 60 degrees. Then angle between velocities, how much will it be? Angle between two lines is 60 degrees. How much will be angle between the perpendiculars? Okay, drawn to those two lines. It's simple, right? Two, you have two lines, angle between them is 60. Okay, there is some angle between two lines. If I say I rotate first line by 90 degrees, okay, I draw perpendicular to first line, or I rotate this line itself by 90 degrees and the second line by 90 degrees. How much will be the angle between the rotated lines now? It will be same angle. Yes, no. Angle between this line and this line is 60 degrees. VA is perpendicular to this one, VB is perpendicular to this one. So if angle between two lines is something, angle between perpendiculars to those two lines will also be equal. Okay. So see, I can draw this VA over here because I want to find out change in velocity. I want to find out change in velocity. So this is VA. Okay. So how much is angle between VA and VB? It's 60 degrees. VA, VB, this angle is 60 degrees. This is VB and this is VA. Magnitude of VA and VB is equal. That means length of this side and this side is equal. And this will be change in velocity. Okay, this is delta V. See, using triangle of vectors addition, you can say VA bar plus delta V is equal to VB bar. Okay, so delta V bar will be equal to what? VB bar minus VA bar. Okay, so I will ask you a question. Length of this side and length of this side is equal. Angle between these two lines is 60 degrees. And I join this thing. So what kind of triangle will I get? You will get equilateral triangle. Okay. So you want magnitude of change in velocity. How much will that be? The same as that of length of this side. Length of this side is how much? 10 meters per second. Therefore, length of this side will also be equal to 10 meters per second. Right? Yes, no? Okay. So actually, this we should do very quickly. Okay. I have explained this. Okay. But this thing should come very fast in our mind that you have initial arc, you have final arc, angle between them is 60. So how much would be the angle between initial and final velocity? It will be same. Okay, then if you like, you can draw a triangle. So angle is 60, this side and this side is equal, then change in velocity would be same as that of length of this side. Okay, so that is how much? 10 meters per second. So this is a trick. Okay, or this is fastest method. Then if you like, you can use final velocity minus the initial velocity formula. So how can you use that? So this is your VA bar, VB bar, this is VA bar. Okay, VB bar minus VA bar, right? You can use this formula. You want to find out VB bar minus VA bar. Okay, so first of all, you will draw minus VA bar, which will be directed like this. How much will be the angle between VB and minus VA? If I draw minus VA, how much will be the angle between them? Oh, Its total angle is 180 degrees and 120 degrees, right? Minus VA will be directed like this. So this much angle, it's 120 degrees. Okay. So therefore, this is like you are finding VB bar plus minus VA bar, right? VB bar plus minus VA bar. Okay. And I want magnitude of this. So I want magnitude of resultant of this. Okay. So what can I do? So its magnitude. So this is the resultant, right? Suppose you have R bar is equal to, or delta V bar is equal to VB bar plus minus VA bar. Okay, this is your delta V bar. And angle between them is, so theta is angle between these two. Theta is equal to 120 degrees. So you can find out delta V will be equal to magnitude of first square Okay, VB square plus VA square plus 2 times of VA into VB multiplied by cos of 120 degrees. Okay, right? So that is, okay, let's add a page here, wrong page. Okay, so you have this thing, and now you can substitute values. So how much is VB? 10. You have 10 square plus 10 square plus 2 times VA into VB, so which is 10 into 10 multiplied by cos of 120 degrees. How much is cos of 120? It's minus cos 60, right? Yes, no. Cos of 180 minus theta is equal to minus cos of theta. Okay, we need to remember these equations. Okay, these conversions, right? So theta is 60 degrees. Therefore, it is cos of 180 minus 60 is cos of 180, right? Sorry, cos of 120. So it will be minus of cos of 60 degrees. Okay, 120 is 180 minus 60. Okay, so theta is equal to 60 degrees. So that is minus cos of 60, and cos 60 is 1 by 2. So it will be minus 1 by 2. So see, what are you getting? This is 10 square plus 10 square, that is 100 plus 100, 200, plus this 2 and 2 will get cancelled out. You have minus 1 multiplied by 100. Okay, that is minus 100. Okay, and this is square root of 100. That means you got 10 meters per second. Okay, so this is another way in which you can find it out. Got it? So answer is 10 meters per second. Okay, but I would say this is fastest way. Okay, this is the fastest way, right? Yes or no? Okay, because in this one, first of all, you have to find out the angle. Okay, this is VA bar, then this will be minus VA bar. Angle between them will be 120 degrees. Then you have to find out delta V. So substitute this, substitute that, etc., etc. Here it is within split of a second. You have first vector, second vector. Magnitude is same. This angle is 60. Magnitude of this side is equal to magnitude of this side. This is the answer. Okay, right. But- Okay, so this is like, this is the fastest way. It's not that every time it will come to your mind. Okay, maybe it will come, maybe it will not come. So still you can solve this question. It would take 1 minute or so, right? If you use this way, it will take very short time. If you use this way, still you can solve it within one minute, right? You can find this angle. Okay, and then what's there, you just have to find out the magnitude of resultant. Okay, anyway, it is simple. Yes, no, it's simple, right? Okay, good. Let's see next question. A particle is moving with a constant. Okay, this was homework question, right? Let's see this question. Okay, what I did is I pressed on that homework question and I added a page from there. Okay, anyways, let's see next question. Car is traveling. By the way, are you solving the homework questions? I'm keeping some questions for daily practice. Okay, I'll give the worksheets also, extra worksheets. I mean, worksheets based upon complete chapter, but I'm leaving some questions. Okay, since last 2 3 sessions, I guess. Okay, since vectors, I'm leaving some questions for daily practice. Are you solving them? Please solve. Okay, okay, please solve. If you have doubts, you can ask me on WhatsApp. I'm leaving them just for the sake of the concepts are fresh in your mind. So based upon those concepts only, that day you will solve some questions. Okay, all right. A car is traveling with linear velocity v on circular road of radius r. If its speed is increasing at the rate of a meters per second square, then the net acceleration will be. Tell me. What is given? Its speed is increasing at the rate of a meters per second square. Which acceleration is this one? Right. Its speed is increasing. That means magnitude of velocity is increasing. So this is tangential acceleration. At is equal to a. Okay. So what will be total acceleration? Now it's simple. A total will be square root of at square plus ac square, and at they're calling as a. So it will be square root of a square plus v square upon r square. Okay. Right. This is centripetal v square upon r. So this is the answer. It is option C. Yes, no. This is also a simple question. And let's see this one, or have I entered? Okay. The particle is moving circle of along circular path of radius 5 meters with uniform speed 5 meters per second. What will be the average acceleration when particle completes half revolution? Okay. Tell me. Let me read it once again. A particle is moving along a circular path of radius 5 meters with a uniform speed of 5 meters per second. What will be average acceleration when particle completes half revolution? Suppose particle starts from that position, okay, from A, and it goes to B. How much will be average acceleration? So this is VA, this is VB. Okay. So magnitude of VA is equal to magnitude of VB. This is given. It's equal to, let's call it V. It is 5 meters per second. How much is time? You can find out time period, right? So time period is 2 pi r divided by V. Okay. And time taken will be half of that because it is performing half revolution. Now question is, how much is change in the velocity? I can say it is VB bar minus VA bar. This is change in velocity. Yes, no? Okay. And can I say VA bar is equal to minus of VB bar? Okay, this is directed like this one is directed like this, opposite to each other. Okay. Yeah. So VA bar is equal to minus of VB bar. So this is VB bar minus of VB bar divided by time. Okay, divided by time. Okay. So how much is, sorry, this will be minus minus plus. So 2 times of VB bar divided by time. Okay. And if you want magnitude only, it will be 2 VB divided by time. Okay. How much is time? So it's half revolution. So that means capital T upon 2. Take that 2 in the numerator. Okay. So in magnitude, I can say average velocity is equal to 2 times V divided by, sorry, 4 times V divided by T. Okay. And T is equal to, this T is equal to 2 pi R upon V. Okay. R is 5, V is 5. So this thing gets cancelled. Right. R is 5, V is also 5. So this thing gets cancelled. 4 by 2 is 2. Or let me substitute all the values. Okay. Otherwise I do it and then I have to explain it once again, right? So V is 5, 4 by 2 is 2. You have this pi multiplied by R is 5 and V is also 5. So this 5 and 5 will get cancelled out. Okay, so it will be 10 divided by pi. This is the answer. Okay, option D, right? So we solved lots of questions, right? So now you will solve same number of questions. Okay, we'll stop here. Please try to solve these questions. Okay, if you have doubts, you can ask me.